Hi, my name is David. I'm a student at the Conservatoire National des Arts et Métiers in France, and I work at the Research and Development Department at 2CRSI. Our project the last year was to industrialize our performance and quality controls for big production runs in HPC manufacturing. We collaborated with Christophe, Narth, and Dorian, Pena, who were very implicated in the project as well. The idea was to scale up and industrialize our quality controls, and our approach was to put in place a modern cluster provisioning tool, deploy a diskless operating system with a minimal Linux image, supporting modern GPUs and modern chipsets, with the possibility to update them as needed, and a toolbox of open source tools to do performance benchmarks and gain information on electricity consumption and component performances. And to fully automatize the process in our production lines. The idea was to put in place a standard provisioning tool. We analyzed different solutions, and in the end we decided to deploy XCAD, an IBM solution, mostly because IBM provides paid support, and there's a good documentation and a vibrant community developing the provisioning tool, and it allowed us to customize our images with the tools we needed, with the scripts we needed, to put in place the controls if the right components are installed in the right products. The idea was to be able to deploy by serial number, by detect the firmware, be sure that every firmware is up to date, to be able to deploy by network switch, by subnetwork, by network, and XCAD allowed us to do that, so that was very interesting for us, and as well to update the firmware automatically. The approach was to have a monitoring system in place and to build up a database on the performance of the components we used, the electricity consumption for different AI applications, and to assure that the products we deliver to our customers are as advertised, as needed, that the right components are installed, that the wiring is working correctly, and for our research and development department, that we gain the necessary information to improve on our products and to get better in the fields of electricity consumption, and to be able to advise our clients on which components are best for which machine learning application or which AI applications or HPC applications. So the basic principle is we have our provisioning server running XCAD, and via the BMC we'll power on the nodes. We'll assign IP addresses. Our CentOS diskless image will be deployed to the RAM of the machines, of the compute nodes. our toolbox will detect the installed hardware and the firmware of the nodes. If necessary, it will perform automatically an update to update the firmware. And then we start our benchmarking process on each node to gain information on how the system performs, if it's coherent with the results we want to see. All this is supervised by our monitoring stations in real time, and as well available to our researchers for later analysis. The future features we imagine are that we further automatize our production runs, that we use the collected data to better advise our clients on which technologies to use, which components to use, and as well gain significant improvements on the electricity consumptions for specific applications. We want to propose an open database. We're interested in exchanging on component performances with the OCP community. The idea is that we could as well go in the direction to try to anticipate future performance on components that are not on the market at the moment, trying to predict component performances before they reach the market, to be able to make better decisions on which kind of technologies to adopt. If you're interested in these kinds of collaborations, please contact Christophe Narth, who worked on this project as well, or Lesia Dimit, our strategic innovation engineer and OCP lead. Thank you very much.